Last question of this calculus practice test says find the area of the region enclosed by f of x equals x squared minus 1 and g of x equals 3. So they're not giving us a ton of information there, but we should recognize that we're asked for the area, which means it's probably going to be an integration question, right? Let's think about our area formula. We usually say area equals the integral from x equals a to x equals b, so the left point to the right point of the top function, or the higher function, minus the bottom function, or the floor. Bottom function. dx, which means we need these functions in terms of x. So if we can figure out which function is on top of this enclosed area, which function is on the bottom, we simply do one minus the other, and it should be good. Let's see if we can draw a quick picture. We should know what x squared minus 1 looks like. It looks something like that, going through minus 1. And y equals 3 is just simply a straight line at 3. So you can see that 3 is the top function and x squared minus 1 is the bottom function. So we've got that. Now we just need to figure out our limits. And those are going to be from the left point where they intersect to the right point where they intersect. How do we find where two curves intersect? You set them equal to each other. So I'm going to say x squared minus 1 equals 3. Which means x squared equals 4, which means x equals plus or minus 2. It's just the plus or minus the square root of 4. So that means this point is negative 2, and this point is 2. Should be pretty clear to see that when you plug 2 or negative 2 into this function, we get 3, and we know every point on the orange line is a y value of 3. So now I can set up my integral, and my area is equal to, the left point is negative 2, the right point is 2, the top function is just y equals 3, and the bottom function is x squared minus 1. Watch your brackets here. Now I used x squared minus 1 because you can see that the integral, or the area of this portion is always from the top to the bottom, but it's always in terms of y, right? If we're measuring that distance, it's this y minus the y point here. But we need it in terms of x because we're moving sideways as we measure all of these different lines and add them all up. That's what the integral is doing. So I'm telling the integral to move from negative 2 to 2 on the x's, which means I need my y's in terms of x here. Okay? So it's the integral from negative 2 to 2. If we clean this up, it's going to be 3 minus x squared plus 1. So it's 4 minus x squared dx. And now we can integrate, which is 4x minus x cubed, go up 1 power and divide, from negative 2 to 2. Plug in the 2 and you get 4 times 2 minus 2 cubed over 3, minus plug in the negative 2. 4 minus 2 minus negative 2 cubed over 3. And this equals 8 minus 8 over 3. Plus 8, careful with your negative signs, minus 8 over 3, which is 16 minus 16 over 3. And if we want one last step, 16 minus 16 over 3 is equal to 32 over 3, just by getting a common denominator. So hopefully you found that helpful. Again, figure out which function is the top one or the higher function, figure out which one's the bottom, either through a picture or picking a point in between the interval and seeing which one gives you the higher y value. And to find the points of intersection, which determine your limits on the integral, set the functions equal to each other, and that will give you your two limits. You can always send us more integration questions. info@arnoldtutoring.com. Thanks.